Hi and welcome to the exam collection. This is just going to be a series of exam questions that you'll more likely see towards the end of the paper. So again, you're getting to practice those grade 4 and 5 questions. The methods that you're going to see me using are the methods that I've obviously used in class with my students. They may be different to the ones that you are using, so just be aware of that. And the way that this will work is you're going to just pause the video, have a go at the question, and then you'll get a walked through model of how you could approach it. And please remember, with maths, usually there's more than one way. So if your approach is different, but you get the same answers and you are correct, do not think that you're doing it wrong. You are probably absolutely fine. Just make sure that you have every step that you're doing written down, so you've got that evidence to show it wasn't a lucky guess or you didn't fumble your way through, you knew what you were doing. Okay, so there's the first question. Hit pause and press play when you're ready. Okay, so all of these questions that we're seeing today have come from a non-calculator paper, so we mustn't be reaching for that calculator. So we've got buses leaving a bus station every 24 and 20 minutes. And we are having to find when they would next leave that bus station at the same time. So this is a lowest common multiple worded question. So the first thing to do would be to work out that lowest common multiple. Now you could start by adding 24 minutes to 9 and working in time, but it's much easier to leave the time to the very end. So I've got a bus leaving every 24 minutes. So I'm going to work out and list some of these. And just to get a feel for it, I'll start the other one as well. 20, 40, 60. I can already tell that obviously they're always going to end in 0. So really I want to work on here until I hit a 0 on the end. So I'm going to keep going. 96 plus 24 is 120. So I actually get it on the very next one. So 120 minutes, remember we're working in minutes, is when they're first back into the bus station together and leaving again together. 120 minutes is 2 hours. So I was at 9, add on my 2 hours, and my answer is 11 a.m. And be really clear about what time of day it is. Okay, you can have 11 o'clock at night, so you must make that absolutely crystal clear in your answer. Okay, next question is just a skills test. There's no application here. So hit pause and press play when you're ready. Okay, so expand means to multiply out. You can see the time sign in the word right there, X for expand. Okay, so I'm going to rewrite this just so I've got a slightly bigger version to work on. So 2 times X is 2X. 2 times 3 is 6, so I've got 6Ys plus 4X. And times here, be very mindful of that negative. That's going to give me minus 4Y. And now I want to collect up all the X's into one group and all the Y's into another. So we've got 2 X's here. It tells me to add another 4. So I've got 6 X's in total. Now, when I take a little look at the Y's, this is telling me I've got 6. It's a positive 6. So I'm at 6 on the number line. When I take away 4, I have 2 left. 2 is positive, so it's plus 2Y. Lots of people can get really muddled over whether to put a negative there or not. So factorize. So F for factorizing. So I've got my 8p minus 12pq. And I'm going to be looking to see what's common between these two terms. Now I can see the 4 times table is common, and I can see that there is a p in both of those terms. So we've got 4p on the outside of our bracket. Factorizing is the opposite of expanding, so we need to get that bracket back into the expression. So 4p, 4 times something is 8. That would be 2. I want 1p here to make 8p, so I don't want to add anything extra here. 2 times 4p is 8p. It's then minus 4s into 12 go 3. I've already got the p on the outside, so I need a q to finish that off. And then again, imagine that expanding. 4 times 3 is 12. The p and the q get squashed to make the 12p q. Okay, next question. So hit pause and press play when you're ready. Okay, so we use something called boxes and labels in the classroom. This is an ideal place to apply it. You don't have to, obviously. I'm going to show this. It's quite a big job with the fact that we're having to look at every single ingredient. So our ingredients make 8 biscuits. So I'm going to start off by just looking at our butter. And I'm going to put a little label so I don't forget what it is I'm doing. Now, I've been given a fact in the question. The fact is that 120 grams will make 8 biscuits. So my fact will go inside my boxes and label grid as 120 grams making 8 biscuits. I've got 330 grams in the question. So that, oops, let's put it in properly. That will go in there. And then I set this up and divide by the trapped number. The trapped number is the number stuck in the corner. I can't slide it out of that position. So I've got 120 is my denominator, 330 times by 8. And that is getting you marks already because you are showing the examiner the maths you need to do. Now, I don't really want to work in such large numbers. I could put 330 times that by 8 in my Chinese grid and then divide through, but it's crazy. These non-calculator questions will always give fractions that cancel down. So we just need to look at how this cancels. Well, the zeros will cancel straight away. And then which times table does both the 12 and the 33 come in? It comes into the 3 times table. So if I divide the top and the bottom by 3, I will end up with 11 over 4. So 11 times 8 is 88. Divide that through by the 4. 4s into 8 go 2, 4s into 8 go 2. So I can get a maximum of 22 biscuits with the butter that I have available. And then I have to repeat that whole process. So I'm going to do sugar, do my grid. The grid just organizes my information. This time I've got 60 grams making me 8 biscuits and 200 in the question. Okay, so cross those off. 6s into 20. Well, I can half this actually. That's going to give me 10 over 3. Okay, so 10 times 8 is 80. Divide that through by 3. 3s into 8 go 2. 2 3s are 6, so that remainder 2. 3s into 20 go 6. And then I could keep going. So 3s into 20 do go 6 with 2 left over. That 6 is just going to keep getting repeated. I know the maximum I can make is 26, but that's irrelevant really because the butter is only going to make me 22. So the maximum that I can make at the moment is 22. And now I repeat the whole thing with my flour. Okay. And as I say, there are other ways to do this. I'm just supporting what we do in class and the methods that we can go to when we can't come up with anything else. So my pairing now is 180 for my 8, and I've got 450. And we start doing our cancelling. This can cancel by 9. They're both in the 9 times table, which is going to give me 5 over 2. 8 5s are 40. Divide that through by 2. And I've got 20. So the maximum number of biscuits that I will be able to make is 20. because the flour is restricting. It doesn't matter that I can make more with these ingredients. If the most I can make is 20 with the flour, then that is the most I'm going to be able to make. Okay. So our next question is a probability question. There's two parts to it, so we'll get it so that you can see everything. And then you are going to hit pause and press play when you're ready. Okay, so these questions are very standard. Usually it is to complete the tree diagram that's already been created for you. So probability, what they're testing here is that you know it adds to 1. So if the probability is 0.4 to win, to not win, it will be 0.6. 0.3 to win, it means a 0.7, and then that gets repeated, and you get 2 marks for filling and completing that. We've got to work out the probability that Wendy wins at Hoopla and at the Coconut Shy. So we follow that pathway. That's her winning at Hoopla and then winning at the Coconut Shy. We're picking up these values as we go. So we've got 0.4 and 0.3. We've got to do something with those numbers. We multiply across. So we're going to times those, which is going to be 0.12. One of the biggest mistakes I see is this, where people do the 4 times 3 is 12, don't really know where to put the decimal in. Remember, probability adds to 1. So an answer greater than 1 is an incorrect answer. So don't make that mistake there. Okay, that's our probability question. Our next question is another really big, full on, lots of words and lots of maths, a bit like the recipe question. So just take your time, work your way through this really carefully and slowly, and then hit play when you are ready. Okay, so again, we're going to be seeing the methods that I use in class. So we use original times multiplier equals result every time we see an increase or decrease question with a percentage. We call it a 2-tick check. So if you can get 2 ticks out of the question, you're going to use this. So I've got my percentage tick. It's on about an increase that is happening. These are charges that are being added, so it's an increase. So the first thing we have to do is work out the multiplier. The multiplier is 100% plus the increase in the question, which is 2.25%. That gives me 102.25%. Percent means out of 100. So at this stage, we divide through by 100 to get our multiplier as a decimal of 1.0225. That has got to be multiplied to the original. The original is £60. We've got £60 as the ticket price. So we're now going to be doing 60 times 1.0225, which can feel pretty daunting when you're on a non-calculator paper. That does not look like a very friendly piece of maths. But if you just relax, trust in your methods, be confident using your methods, and you will be absolutely fine. So we are going to be multiplying 1. We ignore the the decimal to start off with. So we'll just list out these. Okay, so my Chinese grid, which is what we use, has got to have a 1, a 0, a 2, a 2, and a 5. So if we pop it in like that, it's just easier to set up, and then put our diagonals through. It doesn't matter if the diagonals have a bit of a bend in them, as long as they go through the corners. That is the most important thing. So I'm just going to make this a little bit bigger so that I've got space to write into it. So 5 6s are 30, and then anything multiplied by 0 is 0. But please don't think that that's an unnecessary step, because all these digits that we are creating into the grid are really, really important. So we keep multiplying along. So I've got 2 6s are 12, and 2 6s are 12 again. We've got 6 times 0 is 0, and 6 times 1 is 6. And we are then going to fill in all the zeros along the bottom because multiplying by 0 gives us 0. And then we add through these diagonals. So we've got 0 dropping out here, 0 dropping out here. We've got a 5 dropping out, 3, a 1, and a 6. So I'm getting 613500. Now check in with where that decimal place needs to go. 1, 2, 3, 4 movements. So 1, 2, 3, 4 movements. £61.35 is the cost of the ticket with the 2.25% increase. They're also charging, let's make this a little bit smaller so we can see everything. They're also charging 80 pence. So we're going to add our 80 pence on, which is our booking fee. And we would end up with 5, that's 11, carry the 1, £62.15. And that is what rail tickets will charge. You've then got to go through the whole process again for cheap trains. So they're charging 1.5%. So my multiplier here is going to be 100% plus 1.5%, which is 101.5. The decimal version being 1.015. So let's put that in. We've got the digits 1015 to go into the grid. And then put those in. Remember going through the corners because they're slightly different sizes. It's a slight bend. And obviously we're multiplying by 60 again because that's our ticket price. So we go through the motions of the multiplication. So we've got 30, 6, 0, and 6. Then timesing by 0 gives us zeros all the way along the bottom. So 0 drops out, 0 drops out. We've got 3 and a 6. So we've got 9 dropping out. It gets a little bit, we should zoom in so we can see this a little bit better. 3 and 6, look. And then in this one, we've just got zeros again. And then we've got our 6. So we've got 60900. Looking at where the decimal needs to be, 1, 2, 3. So 1, 2, 3. And we've got £60.90 with the charge added onto the ticket price. The booking fee is £1.90. So £1.90 gets added on. So that's 0.8. Carry the 1 is 2. And you've got £62.80. When you compare both those, you can see that our first piece of working out for, was it rail tickets, is the cheapest. Now you must answer the question. Rail tickets is cheaper. Okay, and then that will get you your full marks. Okay, having confidence in your methods is really key to being able to have that kind of resilience with a question like this, because there is a lot of work in it, and there aren't the shortcuts to make it any easier. You might be arguing back that finding 10% halving and halving again could be easier for that first rail tickets working out. But one of the things that we try and do in class is find one method, be confident and really good at that method. And then it doesn't matter what the maths or the question looks like, we can just go straight in with what we've learnt. Okay, our next question is a little bit of standard form. Really, again, classic question to come up. It can come up on calculator or non-calculator. It just happened to be on a non-calculator paper for this particular set of questions. So hit pause, press play when you're ready. Okay, so we're writing this number in standard form. So I rewrite it, give myself a bit of space, do my count. The decimal point needs to be here. The first digit with value, then the point. So 1, 2, 3. We are going to do 3.85 times 10 to the minus, 3, because we moved it 3 places to get it in the right position, and it's a small number, so that negative represents that small number for us. Okay, so 7.291. This is 10 to the power of 5, so it is a big number. That positive power tells me so. So I'm counting 1, 2, 3, 4, 5. I've got a couple of empty buckets appearing. So my final answer tidied up is 72910. For this one, I've got a little bit of work to do. So it's a divide question. So 2.4 divided by 6. I always do the numbers first. I'm going to need to put that into my bus shelter. So 6's into 2 don't go. So I've got 0, carry the 2 over. The decimal point is next. So the decimal point comes up into my answer. 6's into 24 go 4. So for the numerical part of this, I've got an answer of 0.4. Then the powers, 10 to the 10 divided by 10 to the negative 2. The rule for dividing powers is to take away. So I've got 10 take negative 2. Okay, if you want to see that a bit clearer, it's 10 take negative 2. I've got a double negative happening there, so that is going to give me 10 to the power of 12. So I've now got 0.4 times 10 to the 12 as my answer. If I leave it there, I'm going to lose a mark because it's not, even though it looks like standard form, it's not actually standard form yet, because we must have a digit with value and then the decimal point. So that decimal point really needs to be here. So I've got a digit with value. So I am going to be making this side bigger by 1 lot of 10. I'll be timesing by 10. Okay. This side means I've got to make my power smaller by 1, which is 10 to the 11. Okay. If you want to see more about any of these methods, then do check out the content on the channel, because there's all of this in much more detail with a bit of on the how-to videos to help you again. So that is all of the questions that we are doing today. I hope that has been a useful bit of revision for you. I'm going to put a new set out every single Monday so that you have got that extra little something to help you with your revision. So I'll see you again next Monday, unless of course you're tuning in for our Wednesday random exam question.